All right, welcome back. And this is the training data set. So, where are we at here? Okay, we got our 2 terminals. We don't need our desktop one anymore. Okay. Let's go spin up documents, Python, DFFML, operations, plugged in pure DID, or unfortunately named pure ID right now. Okay. Sudo apt or sudo pacman dash syy git. Git is not installed on this thing. Wow, I had really not gotten far through setup then. Okay. Unrecognized archive format. Okay, we need to solve this. We need to solve this. We need to solve this. Okay, ZST Arch. Okay, what are we doing? So our problem is because we're upgrading for 5 years old, and they've changed the okay. You haven't updated in a year and a half. Better wiping it and installing a different distro. Just do a full upgrade to the latest search. I got the package once. Then did pacman static. Let's try this pacman static. See, maybe it's statically compiled pacman. Later version doesn't require the format. Nope, that would be great though. Um, Unrecognized archive format. CST. So here's what I'm going to do. WSL docker run Arch Linux. OS release. What is this? I thought we had Docker on this. Okay, background static. Okay. Docker command not found. Let's just encode. This is really grinding my gears. Docker PS. Okay, Docker run Arch Linux. Okay, so this will download the latest version of Arch Linux. I'm just going to go ahead and extract it. So we're going to do sort of a Hail Mary here. We're just going to overwrite the contents of the root directory. with this new thing. Actually, you know, Docker rm. Okay, so I think what we can do is we could use our switch root. Um, how can we do this? I want to learn more about OverlayFS. How do they do the AB updates on Android? I never got that nailed down. How should we do this? So we can do a chroot into the new Arch Linux environment. We'll just mount the root directory as a volume into there. So run IT, so we're as if we're going to treat the container as if we're a live image pointed at the running system. So Docker run v root mount. Okay, so we're mapping root to mount. We're running Arch Linux and pop us a shell. Great, so let's check out mount. So what's in there? It's our operation not permitted. Operation not permitted. What? Let's try mounting a root only. Operation not permitted. Okay, operation not permitted. Let's check journal control. See if it has anything to say. So, okay. Where are we? All right, remove all Docker rm, Docker rm, Docker ps-aq. That gives you remove all your old containers. All right, I forgot to start these with --rm, rm, it, arch linux. Okay, ls-laf. Okay, so we're seeing there's a permissions problems that happen with Docker every so often. We're running into them right now, probably because we're running on an old version of the kernel here or something. It doesn't really matter. We're actually going to say rmti tail-f dev null, and this should just leave the container running for us. Now we should be able to do docker ps. All right, there it is. Okay, so now we can do docker cp, and let's check out mount. Or let's just ll. Let's mount a RAM disk. So we're going to mount a RAM disk and then basically chroot into the RAM disk. We're going to mount a RAM disk, chroot into the RAM disk, copy the contents of the files within the RAM disk back to the root, and then rerun update grub from the root. Okay. I can never remember. I always use the same article. TempFS, RAMFS. There we go. Something, yeah, something happened there. All right. Sudo mount ramfs temp size for, what is 4? Is that going to be 4 gigabytes? 4G. Yeah, let's do 4G. Okay. Okay, so let's go then copy into mount. Okay, Docker cp this guy root mount ch mod mount operation not permitted. All right, let's run it with sudo. Let's see what happens in mount. All right, there it is. Okay, the question is this running from a RAM disk? Let's find out. This thing is hanging on me. Okay, so RAMFS on mount, type RAMFS, size 4 gigabytes. All right, we can kill that tail. I think it's spinning because of the tail, because that file is not there and it keeps just trying to stat it infinitely. This is pretty bad though. Why is this doing this? It's like, wow, what the fuck is it this? What is this? This is pretty bad. Is it the network? This is really bad. Can I just have a working computer? Can I please just have a working computer? One working Linux computer. I realized I deleted the DigitalOcean droplet. This seemed like it was working. My other server died overnight. I wasn't even touching it when it died. Wow, this thing is like molasses. What's happening here? This is worse than molasses. What is going on? There's no reason for this behavior. What's happening here? Couple interfaces going up and down on Docker. None of that should have done anything like that. It was hanging on me hard. Let's see. Like really weird hanging. Okay. We're gonna assume it's this weird Docker process here. All right, okay, so let's kill that tail. Let's kill it dead, -9. Great. Hopefully that gets rid of any weird behavior that we were seeing there. All right, what's the plan? The plan is sudo chroot mount. Okay. Okay, no proc. Okay, I just ran across a bunch of bind mount commands somewhere. Oh, I almost forgot why we aren't doing this on this computer, because it's causing a blue screen. All right. Okay, so Pac-Man. Install Arch Linux from existing. The bootstrap environment is very bare bones. Okay. All right. So okay, I think we're just going to switch back to DIDs. We're going to switch back to DIDs. We're just going to try to encode them directly right now. Because we're running out of time here. I need to be able to say that. I need to know today whether we can put this on the blockchain or not within DIDs. Okay, so so we are no longer going to use this SSI import service gateway. So we're going to modify our data flow here. We're just going to include this one, pure ID, pure DID. Damn it. Okay. Rerun. This thing just like runs every once in a while. I'm wondering what those fans are all about. Okay. So, import.gateway not found. Okay. So we're just going to define a variable, which is going to be our one for now. So we're basically just saying which one to use, and we're going to comment out that one, and because we're setting the config by name as well, so we need to not do that. All right, there we go. Okay, we're running the pure DID creation. Back to running pure DID creation. See, this is why I have a personal goal to maintain no infrastructure. It's because maintaining infrastructure is obviously an undoable task for me. It just breaks. And I'm also way too cheap to buy new hardware. Or pay 50 cents for a DigitalOcean droplet. So, okay. Maybe that's the root of our problem here. Maybe I should just be less cheap. No. Distributed compute. Okay. So we want to create some signing keys. Let's mess with this a little bit. So what happens if we change this? Just see if anything breaks off the bat. Okay, no. Looks like that's coming through. Okay. Algo 1, resolve peer ID, DID doc 0, algo 1 as resolve peer ID, pure DID, resolve pure DID, pure DID equals pure DID, algo 1, pure DID, algo 1. Okay, so these print out the identifiers themselves, and then look at this algo 2. Looks like it's actually using a JSON web token. So what is the difference here? So this one used this encryption keys and signing keys. So this used this num algo 0 used this inception key, and it said signing keys 0. And then this num algo 2 used signing keys. Okay, and then it came up with this. Okay, so what do we do here? Let's see. So it looks like is pure DID 1 involved anywhere within peer DID2. As object, what is this? So as JSON, okay, that's a real nicely formatted JSON. Okay, from JSON. Okay, so these are the peer DID documents. So do they say, does peer, okay, 2 point, okay, so this algo2, I don't know what the algo2 significance is. What happens if we remove this algo1? Signing key 0. So we're just going to like remove all this stuff, see if they're actually linked to each other here. I'm not clear on if they're really linked or not. We're just going to print algo2. Looks like algo2 prints. So algo2 and, okay, so we're missing some sections. Okay, so that was interesting. So let's take a look here. Let's do a delta. So this is what we had before in algo2, right? Okay, and now let's run it again. I believe we're going to see one more. Nope, it's the exact same. Okay, authentication. So peer DID algo1, I'm thinking it's just a self-signed DID. This service, type DID com messaging, service endpoint routing keys. Okay, so resolve peer DID, DID doc, peer DID. Okay, Python import peer DID, peer DID dot path. Okay, there it is. We're going to go dive in. What do we got? Okay, got a bunch of compiled files. How do we use this thing? How do we use this thing? Okay, so git grep did doc peer did. Okay, okay, we're not in a git repo. Grep rn peer did doc peer did. Where are we? Okay, we're on hostname. We're on this system. Okay, so creates an instance of DID doc JSON. Okay, peer DID. What is this peer DID? So I don't understand the difference between peer DID and peer DID doc. I think peer DID wraps DID doc. Create peer DID generates a peer DID. Okay, no malgo2. According to the second algorithm. Okay, for this type of algorithm, DID doc can be obtained from peer DID. Okay, signing keys, encryption keys, JSON C, or the DID specification. So the DID, okay, so the DID doc, so it generates peer ID according to 0 algorithm. Okay, so we need to read this. For this type of algorithm, DID doc can be obtained from peer ID. Okay, so remember, we want a document. We want DID doc, right? We want to figure out how to put our manifest in there. Okay, let's read this. Okay, so this is, oh yeah, we had this up. Okay, so here's our method prefix, num algo. Okay, the number of the algorithm. Okay, so there's version 1 and version 0, 1, 2, maybe some other ones. We've seen version 0 and version 2 so far. Okay, in this version of the spec, multi-codec descriptor for algo num algo equals 0 is dependent on key type and exactly matches the descriptor that would be used for the same value of DID key. The multi-codec description for num algo equals 1 is byte pair blank blank blank. 1220, hex 1220, which says that it follows SHA-2 256 hash, 32 bytes long. Size is included because although SHA-256 is known to be good, produce 32 byte diver checks, other hash algorithms has very little length. So why don't we leverage, I think we need to comment back, let's comment back to Brooklyn on that UCAN thread. Where is that discussions? Okay. Where's that UCAN thread? See, this is when I want to be like, Alice, where's the UCAN thread? Can you comment on the UCAN thread? just would be great, right? We're going to make it happen. Okay, so codec freedom. Okay, so DIDs allowed for multiple codec options via numalgo. Should we follow? Should that be followed as best practice? Should that be considered best practice and followed in this instance? Okay, so I believe that's what I'm reading here. So method specific identifier. So core characteristics method name peer. Okay, DID must be identified DID peer. Okay, so this is a peer DID. Okay, so different. Oh, you can have different distributed. Oh. Okay. Okay, this makes more sense. Okay, so you have your DID spec, which is the core of everything. You have your peer DID spec, which finds this is the thing we care about, this linkage, right? And then the TBDEX folks, they have their message protocol, which is using DIDs, and they care about the coins that are within DIDs. They're using this JSON web message. Thank God, that's another great thing. God, all these people are defining so much stuff within like the web space. If you've done web development, you're probably loving all of this. Um, okay, key DID key. Okay. So DID key is that thing that we saw from we saw DID key from where was it? Last night. Yeah, it may have been off the stream. I was poking around, but not that much. Mostly just trying to get things booting. So DID key DINACL. NACL is lightweight DID method, complete with identity creation tools, encryption, JSON web token signing. Repository has been okay, so use DID key. So basically, forget about that. So DID key. Okay, DID key transmute. Okay, let's grab this. Okay, DID method specification. Okay, DID method, which is offline friendly. Love it. Cryptographically self-certifying, requires no trusted blockchain certificate or authorities, is ideal for ephemeral use under construction. Okay, so we have an ephemeral use case with these little inputs, right? We want to be able to blow them up when we want to get rid of them within the cached service. So it looks like DID NACL. Okay, so okay, okay, to help us understand better method spec identifier. So, oops. Okay. Led us to find out that DID NACL is deprecated in favor of DID key, which will be used by TBDEX folks. Peer DID is the linked list version of DIDs. DID peer. Okay, so these are like package URLs. And then each underneath them, beautiful. So basically you say this is my namespace, right? So DID, this is a distributed identifier. What namespace does it exist in? How do you interpret the format? So this is a manifest. So the manifest, so this DID, a DID itself is a manifest. It tells us format name via DID format name. It tells us format version optionally encoded for peer DID encoded into numalgo, which is this method specific, which is maybe this method specific identifier. Are we streaming? Okay, we are streaming. Okay. So we could say peer DIDs allow for multiple codecs. Should that be considered as vectors and followed in this instance? Okay, I think that is what we want to know. So method specific identifier, core characteristics. Okay, let's actually link to core characteristics because that is a little bit more helpful. So, okay. DID key, method specification, DID method, which is offline friendly. Okay, so what is a DID method? I think I'm not understanding what that is. Resolution methods. Okay, so DID method must define exactly one method specific DID scheme that is identified by exactly one method as specified by the method name of the DID syntax. The DID method specification must specify how to generate the method specific ID component of its ID. Oh, this is good. Okay, DID method specification. This is good. Method scheme. Method scheme. DID method. Okay. Method name follows the colon and terminates the second colon. Okay, method name, so scheme, okay, terminates with the second colon. Okay, so this is the DID scheme. Okay, DID method is how a specific DID method scheme is implemented. So like pure DID, the DID method is defined. So the key DID is, okay, so pure DID is a DID method. Okay, so the namespace, so what looks like the namespace is, so DID example is the DID method example. DID peer is the DID method peer. DID key is the DID method. Aha, okay, and so then the schema, so these are manifests. These are manifests. A DID is a manifest. A DID is a manifest. The DID method encodes the the information needed for the next phase parser for our shim. Okay. Okay, all right, okay, so what do we want to do with this information? So we have these peer DIDs. So can we issue our own, should we be looking at that? Should we be looking at building something on top of a DID? Should we be looking at context authentication? Let's go run this thing again. Show me what it looks like. Okay, so service key agreement, authentication service. Okay, so I'm thinking, how do we relate one peer DID to another to a non-peer DID? We want to relate it to another DID. Okay. So we want to create distributed identifier. Okay, so let's see, does software, OBS Studio connection. All right, so key is going to be used by TVDex. Peer is going to be used by us to relate DIDs. Okay, so this version of the spec. Okay, so is dependent. So Okay, in this version of the spec, the multi-codec descriptor. So multi-codec descriptor. Where's the multi-codec descriptor? Okay, this is just the multi-codec descriptor for numalgo1 is dependent on the key type and exact measure. It would be using same value in DID key. Okay, so basically, so when numalgo equals 0, the cold multi For this version of spec, the multi-codec descriptor for num algo. Okay, multi-codec is here in the method specific identifier. Composition of the pure DID value is base 58 to income bias. I have no idea. I've never seen those before. Transform Z means base 58. Numeric bias. Okay, and basis, and that's what we said. Okay, so num byte pair, which says that what follows is okay. So multi-codec descriptor. Okay, so this is okay. It's 32 bytes. When it means SHA-2 256 hash, says it follows as a SHA. Okay, so basically when you see a multi-codec of which is 2 bytes, looks like multi-codec itself is the multi-codec descriptor is 2 bytes long. It's dependent on the key type and exact match the descriptor. Multi-codec descriptor from numalgo 1 is byte pair. Okay. Okay, so no, when it is numalgo 0, then we treat it exactly like we treat the multi-codec descriptor as being dependent on key type, and we exactly matches the descriptor that would be used for the same value. And so then we should treat the descriptor treat the descriptor as if it conforms to the DID key spec. Okay. Multi-codec descriptor for number 1 is this thing that signifies SHA-256, and it says that the numeric basis that follows is a SHA-256 hash, which is 32 bytes long. The size is included because although it is known to the other hash algorithms, so it could change the hash algorithm. Okay, so is 20 mean 32? I think x20 is 32 and maybe x12 is 256. The transform is base 58, representative of a multi-base prefix. Z, okay, base 58 BTC, and the ANF means Bitcoin base 58 character inventory. For brevity, we omit the expansion. See the regex matching for details. The format of the DID value is intended to be future-proof, offering 3 extendable self. Okay, so I think we can safely comment to Brooklyn now. Okay. Okay, maybe we should just say. All right, we'll just say we just noticed this, right? Then she can do whatever she wants with that information. Okay, so method 0, inception key without doc. Method 1, Genesis doc. Create a Genesis version of the DID text from the DID doc for the Genesis version must define a single key with a register privilege. The inception key is a key that creates the DID and authenticates with exchanging with the first peer. It should also include this enough state that subsequent evolutions to the doc are authorized. Otherwise, the doc is static, suitable only for layer 2 use. Okay, we only want a static doc right now. It must not include the DID itself, either the root DID property or its value. This lets the doc be created without knowing the DID's value in advance. Suppressing DID value creates a stored variant of the pure DID as opposed to a resultant variant. Okay, basically, yeah, you sort of get into this problem of what's the actual hash, is my guess. For example, each controller property of a verification method that it is owned by this DID would say controller ID. Calculate the hash of the bytes in the variant of the Genesis version of DID, make the value. By hashing the stored variant, we avoid the circular problem, of the DID that's in the data that being hashed. That means that the pure DID doc must be resolved by converting a stored variant of the DID doc into a resolved variant by inserting the value of the DID being resolved. By deriving the numeric basis from the DID from the Genesis version of the DID doc, Genesis version of the DID doc. The DID can begin its life cycle with any number of keys and endpoints, including protective M of N policies. The inception key is part of the Genesis state that's true bedrock. The information is optimal and can be thought of as a sort of pre-rotation or pre-evolution. Root of trust for period DIDs in this root of trust for period DIDs in the entropy in is the entropy in the inception key. The inception P must be new for each DID, must not be ever be reused, and must. Okay, so we have to make sure that PID self-cert property. Okay. Any DID method that does not guarantee the chain of custody of the DID between when it is created and when it is shared, written to that lacks the quality and is acceptable. Okay, so we need to make sure that protect against anyone can initialize. Okay, so I think this is sort of where the DIDs have to sign. Yeah, okay. Thank God they finally made this based off of asymmetric keys. It's about time. Okay. Multiple inception key without doc. Okay, so that's version 2, and that's what we saw here, basically, right? And so basically this looks like there's some kind of numalgo 2 similar to 0, ability to specify additional keys in the generated DID doc. This is necessary when both the encryption key and signing key are required. Okay, when resolving the pure DID, okay, recognizing and handling pure DIDs. All right, DID docs, backing storage. Should just store a few, right? First glance, it seems that parties dealing in pure DID docs should just store raw DID docs. However, this is only viable answer for the lower 2 layers of support for pure DIDs. Anytime a DID doc evolves, proof that the evolution is authorized must be found in the DID doc's previous state. An agent is offline for an extended period, Frona's loss. Multiple evolutions may have occurred by the time it reconnects. It cannot accept the latest state of the doc without validating the sequence of changes it underwent to get there. Agents must be able to prove to one another that the state they hold is correct, and when they must answer questions about what the state used to be and who authorized changes when. This means that updatable PID DID docs need to be associated with some kind of backing storage, adds metadata and history to the simple content of the docs themselves. Backing storage is updatable PID docs for updated for a sequence of deltas. Each delta is a JSON object in this form. Okay, so basically here a change fragment is the supposed version of DID doc. Okay, so we found out about, we're looking here about protocols. So there's this whole change management thing. Um, Rules and agents and protocols. We call this peer DID method. Enables as describes, we call this the peer DID method because it enables peers to exchange DIDs without recourse to a central authority. Thus, we expect all participants in the protocol to play the same peer role and operate by the same rules. In this case, at a high level. However, at another level of detail, each peer may interact through various pieces of software and hardware that proxy them. It may need to reveal a modest amount of information about such agents to achieve cooperative security. For example, Alice may control 3 devices and may wish to protect herself from hacking by saying at least 2 of her existing devices must agree before a new device can be added or an existing device can be revoked. This requires her to share her M of N authorization policy with Bob and enough information about agent keys that he can validate a multi-party digital signature. Thus, our protocol must occasionally contemplate details about this more granular level of each peer's sovereign domain. Let's make sure we understand this M of N. Updated it doesn't contemplate custom authorizations such as peers might develop to give each other spending limits or access sensitive data. These matters are better formalized with some of a verifiable credential. This is where we talked about our provenance information, right? And we can use the DIDs and the provenance information together to, build out, our chains of trust, decide what we want to do with this information. Okay, so the more I'm looking at this, the more I'm thinking we just need to create DIDs and then we can use the peer DIDs to link them. And I think that's what we initially said. So I'm just struggling here. Where do you put the data? Okay, so the peer DIDs link the stuff. I don't see one DID interacting with the other DID in this example, right? Okay, here's the central spec. Simple example. DID method, method specific identifier. Okay, here's the document used to authenticate. Okay, and here's the DID URI identifier. So the document contains information such as ways to cryptographically authenticate a DID controller. Okay, this is the controller of a DID. Entity has the, okay, so this is whoever has the keys. Okay, so what should we do? So DID method. So we have key, we have peer. What other methods exist? Method registry. I think we looked at this. Yeah. Okay. Okay. Should we look at other DID methods? Maybe we'll create our data within another DID method for now and link later for context. Identity aware contexts have a peer DID which exposes links data from our DIDs attached to individual inputs objects, maybe during write out. Okay, let's take a look at the other methods. See if somebody else has already come to these conclusions, probably, usually. DID method registry. Did I put that link? I did put that link. Great. Okay. DID URL. Yeah, this is the thing that I saw that I was like, this is great. That's how I knew we liked this. So what are methods? Data model. Representation specific entries, domain specific. Okay, service endpoint. Operate on behalf of a DID subject. Verifiable. Resource to examples, DID documents, capability delegation, assertion method, verification method, verification, proving. Okay, permanent resident card. Okay, so here, credential subject. Okay, what is this? So here's some data, right? Here's finally some data. Citizenship. Proving encrypting. Okay. Okay. It's taken me quite a while to decipher this stuff. All right. Yeah, see, this is perfect. I saw this and I was like, this has got to be perfect. The question is how. Okay, multiple DID controllers. Referring to a DID document. Where did that go? Where did that list of things? Answer ends. References. DID revolution. Okay, there's a repo that has all of these distributed identifiers registered. DID method registry. Okay, DID spec registries. This is it. Okay, here. This is what we want. DID methods. Okay. Blockchain manager, Spruce, Uport. All these are blockchainy things. Trusted digital web, Hydra, peer. Okay, here's the peer stuff. Ledger agnostic, Ocean protocol. All of this is like so not helpful. This is just names of things. What do they do? What do they do? Okay, so let's suggest including descriptions. Names not entirely helpful. Right. This is the problem anytime you do something like this where you let everybody create whatever identifiers they want, you end up with several of them meaning the same thing usually. So unfortunately, I'm worried that we're going to go risk um, putting in business requirements. DID method. Site OS supports private depending on public DIDs, speed of transaction. What is Site OS DID method? What is Site OS? SSI Data Management Services, Self-Sovereign Identity, Trusted Digital Web, IPFS, Intra Blockchain, MasterCard, Icon. Okay, Fabric, Workday. Interesting. Yeah, this stuff is for sure the future. I mean, the interoperability here. It's confusing because of all the layers of indirection, right? But the interoperability, obviously, the layers of indirection, this is exactly what we've been doing, here too, is just, by introducing these layers of abstraction, you get, you know, huge potential for interoperability, right? What is this? Heterogeneous block settings for single DIG. Proof of a specific address. Okay, I think let's go ahead and see what's out there. DID null. Uh, let's look for supply chain, maybe software. Marking DID get as withdrawn. Why? Developer identity provenance and Git repos are being authentic data provenance logs. So DID are unusable. Be very helpful. They've done usable handwritten. The key points are DID URIs conflate identifying and locating and aren't self-certifying each with a pet backend proof of existence, supporting all of them. DID documents don't provide any means for accessing key history, nor is there any group. Okay. Looks like pure DIDs do that. DID implementations are unique. Expanded that created 90 different protocols and data silos is beyond my comprehension. Okay, but this is the thing. This is the thing. It's hard, but by exposing the data model, you allow for you allow for analysis to tell us what is, um, okay, we're going to work on this because this is what we want. We want Git. So DID Git, authentic. Okay. It's also, okay, DID documents. Okay. These people don't UI like DID URIs. Conflates identification with location, causing complete chaos in the implementation. So this DID string identifies the DID subject and resolves the by creating a standard UI that both it has created a ridiculous explosion of pet storage and provenance solutions, each one having their own decentralized identity method in the registry. Yeah, most of it require access to a running node. Okay. Second flaw is ignoring the fact that test-based documents were chosen for byte-sensitive digitally signed documents. The existing standard simply doesn't meet the requirements of Internet Serial Provenance Digital Identity Solution. DID documents completely ignore time dimension. Put more precisely, they provide no solution for digital identities over time. Good hygiene, promise portability. Okay. Status. This doesn't look to be active though. This looks like a bunch of people who just up and left. Public square. Okay, well, you know, this guy does it not like DIDs, but has he done anything else? Let's see. Dave. Okay. He basically dropped off the map. That doesn't help us. Well, we'll reach out to Dave and see if he's been up to anything, because we want to make sure we get his inputs. Obviously, he did some thinking on this. Reach out to Dave to see why, to see if anything has been up with his evolution off DIDs. All right, so let's just, I think DIDs are, you know, we can at least, like we talked about, if there's something wrong, it's okay. We just make a DID. We can link down the chain later. Doesn't matter. So let's go ahead and investigate this Git URL spec. Okay. 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 Puzzle and solution scripts. Digital signature. Digital sign events. For a stack exchange function. Puzzle server again. Flexibility and controllership of the problem to allow more complex atomic swaps of controllers. Okay, so this is why we're basically saying we're just going to do some on-chain, some off-chain stuff. I don't think we really need to care about this right now. I think document, model document, rice model, model document evidence, model document evidence. Oh, okay. So I think what we want to do is let's go create some DIDs and then let's try to, for input objects, this definitely is confusing. Let's go to the method spec registries, JSON schemas, core schema. Okay, great. See, as long as we've got manifests, we're happy. Okay. What is, so this basically says, okay, DID document, claim, service proof. Okay. Okay, so DID resolver, DID dereferencer, DID method operates verifiable data registry recorded on DID document recorded on verifiable data registry. DID URL dereferencer. Okay. Let's piggyback off of service for now. Service endpoint. Earning keys accept. Let's just piggyback off of service. So what is within service? Service. Service. Service authorization verification. Adding a service. Okay. If there's some sort of field that we can use to hijack, like we could hijack service endpoint. Why don't we hijack service endpoint and put a data flow in there? Server likes that idea. So what should we say? Maybe we'll do a URL. So maybe service endpoint. Maybe we follow the same scheme that they followed when they defined the peer DIDs. And we say method prefix, numalgo transformation, numeric basis. Okay, composition of peer DID value. So this is our thought. This is our system context. The, the, the top level system context will be something that reads the DID in this case. So this is the next context. We want to know, where do we get this information, right? So let's go ahead and make sure that our URL is what other people would think. So let's do, diffml or github.io/diffml/did peer. Okay, did peer, and then what do we want to do? Hash. We'll do a hash, and then we'll encode. So we'll do a hash there. This service endpoint. I'm assuming that this thing won't change. Basically, I'm assuming that this thing is cryptographically signed. Okay, let's hope. Type DIDCOM messaging, service endpoint. Type, okay, let's call it open architecture, service endpoint. Do we have restrictions on service endpoint? What can we put there? Service endpoint. This is example multi-peer KD. It doesn't say type, common string and private variation. Common string purpose code list. Service. Let's go to the peer DID spec. Service endpoint. Service. Okay, general description of service and change parameters. Type. General description. ID. Agent. Okay, so maybe we can use ID for the context. ID. So maybe we can, oops, sorry. Open architecture, service endpoint. So maybe we can parse a DID and then treat these as different, like, what is this? Open architecture. Let's just do the whole thing. So we'll just say service open architecture ID. You know, we'll self-encode this. So we'll just say open architecture and it'll be self-descriptive, right? So service endpoint. Okay, so if you add an ID, okay. So ID architecture, okay, service endpoint, and then we're going to encode. All right, so, and what we call this? Manifest. Okay, so encoded manifest. Encoded manifest equals self dot parent dot all right, so we're going to come in here. Okay, so self dot parent, self dot dict. What do we got? I think we have CTX. Yeah. Okay, so self dot parent CTX run subflow. Why is this thing run subflow? Did I name it run subflow somehow? No idea. I don't know why I'm messing with the interpreter. Okay. Come on, we got 2 minutes to encode a DID. Encoded manifest is not defined. Self.parent.octx.config or dot. I know we have the data flow somewhere. Okay, has no object. OCTX. Where is it? Where is it? Come on, give me the data flow. Give me the data flow. Data flow. There it is. Give me the data flow. Come on, 1 minute. Import JSON. Data flow equals. Okay. Service plus equals encoded manifest plus equals. There we go. Did we do it? We put, where's the fucking data flow? Oh, config. JSON dumps. Print data flow objects. Ah, we're close. All right. Okay, come on. Come on. Fuck. All right. I have to go. God damn it. I'm so close. Service is not a valid JSON. Service is not valid JSON. Service is not valid JSON. Okay, here we go. Service equals. Okay. Boom! Yes! We're on chain. Fuck yeah. All right, peace out.